Good morning, everyone, and welcome to today's edition of a Digital Discovery webinar. Today's presentation will be about IoT, or Internet of Things, equipment and a process that can help you improve your productivity and performance in manufacturing by making better use of the data that your existing equipment is already capturing. All right, well, my name is Mark Sewell. I'm a consultant at Catalyst Connection, and one of the programs that I support is the Digital Bridge program. This is funded by the EDA Build Back Better legislation and supports the New Economy Coalition in southwestern Pennsylvania, and with the principal goal of assisting regional manufacturers with technology adoption. There are several partners of Catalyst Connection on the Digital Bridge team, including, as you can see, University of Pittsburgh, Carnegie-Mellon University Manufacturing Futures Institute, the Penn State Digital Foundry at Penn State New Kensington, Pittsburgh Technology Council, and our economic development partner, JARI, from the Johnstown region. The Digital Bridge program, again, is intended to assist manufacturers with adopting advanced technologies, particularly Industry 4.0 technologies. And there are a wide range of resources that the program includes: technical assistance, supporting the manufacturers, exploring and implementing those technologies. In some cases, access to capital. We have two different grant programs under Digital Bridge that can help support manufacturers by offsetting part of the cost of evaluating and implementing advanced technologies, and in other features and programs beneficial to local manufacturers, supporting their technology adoption efforts. Again, the focus of the Digital Bridge is Industry 4.0 technologies and major categories: robotics and automation, digitization, and today's exploration of IoT technology and some applications that may be the sort of thing that your business could adopt. That's an example there: additive manufacturing and cybersecurity. So basically, manufacturers can take advantage of the program to help them support their efforts to implement advanced technologies in any of these categories. Today's session and all other of the Digital Discovery webinars are recorded, and so past sessions and this one will be shortly, in a matter of days, available for you to review on our website. In addition, during today's presentation, if you have any questions, please put those questions in the chat section, and we'll make sure that we address those questions by the end of the presentation. Now it's my pleasure to introduce our speaker today. He is Gary Kiliany. Gary is the CEO and co-founder of Interstacks, and that is an industrial Internet of Things, or IoT, company based in Pittsburgh. Gary is a Carnegie-Mellon University electrical engineering alum, and he has previously founded two other technology companies here in Pittsburgh. And I'm happy to turn things over to Gary now.
Great, thanks. Thanks to the team at Catalyst for arranging this and all the work they do in helping manufacturers. So I'm Gary Kiliany, CEO and co-founder of Interstacks, and we are based here in Pittsburgh. My email is gary@interstacks.com. So we help companies capture data, information from their machines and sensors, analyze it, and then send alerts based on the real-time information that's flowing in from their machines. And why do we want to do this? Increase productivity, lower maintenance costs. Okay, so why do we want to get capture data from our machines or industrial processes? increase productivity and lower maintenance costs. So if you know when a machine's going to break in advance, you can decrease plant downtime. And if you're running a factory and you have lots of machines, you can make decisions minute by minute rather than uh, daily or weekly. So it's all about real-time information, so you can increase productivity and lower those maintenance costs. So it turns out very few machines in factories have connectivity. 85% of assets remain unconnected. And there's a bunch of reasons for this. There's just tons of incompatible technical standards that are out there. And every place we work with has a giant collection of machines built in every decade from 50 years ago, 40 years ago, 30 years ago to yesterday. So there's just a wide mix of machines, and that makes it difficult. It makes it difficult to extract data, get good information. So most operations managers are flying blind. They're using Post-it notes, clipboards, whiteboards, Excel sheets on daily, weekly, monthly to try to get a handle on what's going on with their operations. So the steps here are pretty simple. How are we going to capture data? First, we got to capture it using either sensors or machine data feeds or attaching sensors around machines and processes. We make a set of modular electronic blocks. We call them stacks. They're just like Lego blocks for electronics. And the reason for that is, again, because of all the incompatible technical standards, you need a wide assortment of electrical ways to get the connectivity to all the thousands of different kinds of sensors, thousands of different kinds of machines. So we have conversations with people, and then you pick from a menu of blocks and snap them together. They just stack on top of each other so that you can capture the data. We then send the data over the internet using Ethernet, Wi-Fi, or the cell data network. We're doing lots with cell data networks all over the world. We take care of everything. The stacks, electronic hardware themselves, is pre-programmed to capture the data from whatever machine or machines or sensors are necessary. And then the data is sent over the internet to a cloud dashboard that runs inside of any web browser. So again, you've got machines and sensors. You got to have a method to capture the data using all different kinds of electrical and software requirements. You're sending it over the internet, Ethernet, Wi-Fi, or cell data, and then you're seeing it on a web browser, and that's any web browser, phone, tablet, laptop. All the data is saved. In our case, our cloud dashboard is built on top of Amazon Web Services, AWS, so it scales immediately and runs on data centers, again, all over the world. So we have many thousands, tens of thousands of real-time data streams coming in second by second from all over the world. And then you want to get text or email alerts based on criteria you select. So it could be a machine is down for 5 minutes and you want the plant manager to know. It could be that the parts going in or out of a machine are above or below a threshold. It could be sensor data, temperature is too hot, temperature is too cold. So those are the pieces: capture, analyze, and send alerts. So one of the tricks is, how do we get data from all these legacy, what are termed legacy, brownfield industrial operations and machines? And it turns out there are thousands of sensors to choose from. That's part of why we have the Lego blocks for electronics, because all of these sensors use different interfaces, different electrical ways to get their information out and capture it so that we can then save it in a database forever, view it in analytics, reporting, etc. So just to give a sense, one of the things we say to people, just like it, it there's, you can imagine, if you can imagine it, there's a way to do it. There's always a way to get information from an industrial process. And these are some of the categories and some of the more popular things that are used. As I said, we don't make sensors. There's 1,000 different sensor manufacturers. We're very familiar with what's out there, and we've worked with hundreds of different kinds of things. One of the popular ones is this top left corner is called a CT sensor or a power sensor. It's just a little donut, and our goal here is to be non-disruptive, right? You don't want to have to shut down the plant or factory or machine in order to add real-time information. So we start with finding very, very non-disruptive, easy ways to how can we get information. So these CT sensors or current transducers, they're just little donut magnets that snap around one of the AC power lines going to a machine. And then what you can do is sample these sensors every second, and you can detect, is the machine off, is the machine on, is the machine on load, is it operating? We have many installations that I'll get into on use cases where this is just critical information. If it's a machine that is doing stamping or sawing or cutting, oftentimes, like with cutting or saws, oftentimes we can even count the number of cuts by just looking at the power profile. Because as you can imagine, the power profile can change across an operation. And so that varies by machine. And so these get installed, and we look at the raw data coming off of the power consumption and talk with the user about what information can be gleaned from that. So those are popular. Mechanical switches. So there's a lot of machines where you're stamping or pressing, or there's a machine cycle. You can use mechanical switches. There's a lot of processes where you want to count parts going in or out of something. So one of the big themes here, it's certainly the case that every end user is unique, every machine is unique, but there are certainly some commonalities. And one is tracking on, off, on load times by machine, by shift. Another is counting, whether it's machine cycle times or parts going in and out of a process. So there's a lot of on, off, on load, a lot of counting. So with counting, you've got mechanical switches, you have optical switches, where you have an optical beam that can count, again, in any of those things. These are, bottom left is a measuring wheel. We use that in proximity sensors. A lot of times there's a big roll of sheet metal or cable or wire that's feeding or coming out of a machine, and you can count rotations of a wheel. Vibration sensing, very popular. We work with both wireless Bluetooth and wired vibration sensors. This is big for preventative maintenance. So pumps, motors, conveyors, machine tools. We have a bunch of customers monitoring their customers' use of machine tools to look for excessive wear. DC voltage and current. This is becoming very popular around solar panels, batteries, backup batteries, etc. Gases, CO2, light level, temperature, a lot of cold chain work. We have a giant project with frozen food, Tyson Foods and their ilk. Pressure sensors, water, fluid flow, tank level, tanks, right? A lot of processes use tank levels. PLCs and other machines can have digital data feeds that we can read. So some of these standards are RS-485, RS-232, Ethernet, and so you connect a cable from the PLC or machine to our electronic stacks, and software in the stack reads information about the state of the machine. We have many, many projects where we're connecting information from a PLC to the cell data network that then goes to the cloud dashboards. Scales are big in a lot of processes. Most of those have an RS-232 digital data feed. So this just gives you a little flavor of, to kind of spark your imagination and creativity versus saying, oh, there's no way I'm going to get anything useful out of this, big honking piece of metal machine that's been here for 30 years. There's always a way to get something. Barcode scanning. So this is pretty popular. One of the advantages of kind of the Lego block approach to the electronics that capture the data is you can snap on all different kinds of things, one of which is a block that talks to barcode scanners. Barcode scanners are great for quick factory floor data entry. So that could be the SKU, the work order number. What's really popular is reason for machine downtime. So there is a paper sheet that sits next to the machine, and it has a list of reasons why the machine is down. Next to them is a barcode. What the operator can do is just barcode scan the reason. That's time-stamped, saved in the database, saved forever. So everyone can analyze what are the reasons for that machine being down. So I just, this slide is important because a lot of times people will stop at the, there's a little bit of creativity required, but we've never seen a situation, a process or a machine that it's not possible by attaching some external sensors or getting some data feeds that we can't get really good real-time, to the second information. So once you capture the data, you're sending it up over the internet to the cloud platform. As I said, it's running on top of AWS, Amazon Web Services. Data is saved forever, so you can go backwards and forwards through time on all the data and information feeds. And what you do is you put together the dashboards. It's very easy to do. It's just drag and drop the various analytic blocks. We call them widgets. Some people call them cards. There's a lot of different ones. So if you think about at the lowest level, a raw signal coming in, and this is just a line chart. So here's time by second, and this might be value. This might be the power consumption that we talked about from a current sensor. So there are a number of visualization views along those lines. Then we get into some analytics, and what you really want to see, would be a bar chart of on, off, and on load. So you would have a bar chart and tables by hour showing minutes and seconds or percentage that the machine is in a particular state, on, off, on load. And again, you can move backwards and forwards through time. Counts, see a bar charts of counts per hour, per machine. This is a table view, the by shift by machine view. The idea is you can define shift times across the columns. The rows can be every machine, and you can see whatever is relevant for that machine, whether it be counts or machine states. And then text and email alerts. So you can set up criteria, as I mentioned, so that a condition that you want to look into more deeply, or is some condition that requires attention, as I said, machine off for 5 minutes, and a text or email is sent. So this is kind of the flow. So the electronics are capturing data from sensors and machines. Then you're saving it in a database, and then you're using visualization dashboards that can be viewed on phone, tablets, and laptops. So you're getting real-time information to increase productivity and lower maintenance costs. As I said, if it's a vibration sensor, maybe get a text alert saying vibration on pump 7 is above norm. If it's productivity, you go down your machines and you see machine 6 is only running at 20% capacity versus your nominal 80% capacity. Lots of use cases. Every project is its own story. As I said, there are commonalities, but I'll touch on a few. Here's a company. It's a company called MKS Instruments, a giant publicly held company, but they do a lot with lens grinding and polishing machines. A picture a room with 100 of these, and this is doing the percentage utilization, on, off, on load, and there's a set of alerts around that utilization. The big motivator for them was they just have too many orders. What we see to get people to move from the clipboards and the post-it notes is either they can't get enough workers, and so productivity is impacted, or there's high turnover in the workforce, or they're just getting way too many orders, and they really have to squeeze out every percentage point of productivity in that facility. So these are using the power sensors, the CT sensors that just go to the power of these machines, and it turns out we can tell a lot about what's going on with the lens grinding and polishing machines. There's a company that does utility cable wire, and here, coming out of the machines, there are big reels that are rotating as the utility cable wire is being manufactured. And so we count the rotations of that. Here's a somewhat similar thing, a sheet metal dispenser. So the bottom right use case, these guys make conduit for HVAC ductwork. This is sheet metal rolls of sheet metal steel, and their problem was too much inventory on the floor because they didn't know how much was going in and how much was going out at enough granularity. So here again, we're counting rotations. There's actually a measuring wheel here that's measuring the feet of sheet metal that is dispensed from this roll as it rotates. So the solar panel battery thing I mentioned, doing a lot with water treatment, water quality. This microturbine generator, we also enable remote monitoring for people that make machines. So we work with OEMs to add remote monitoring features to their product. This is a company called Capstone Green Energy that makes, you can think of them as power generators that they drop on site, but they're fueled by natural gas, hydrogen, or propane. And so what we do is capture data from their turbines, from their generators, and send that to the visualization database. This company, Bearing Lubrication System, again, this is an OEM that makes ultrasonic sensors for bearing wear and lubricating bearings. That's a big failure mode. And we capture data from their sensors and package it up and put it on dashboards. Here again, alerts are generated if the sensor indicates there's bearing wear or soon to be bearing failure. It gets lubricated and so on. So we're about out of time here. We got a couple minutes left. As I said, you can break this down fairly simply. What do you want to accomplish? There's always a way to do it. You need to capture the data using some kind of electronics and some kind of sensors or data feeds from a machine, and then send that to a server with a database and visualization tools to let you view that data and generate alerts based on conditions that are out of kilter. Lots of people are doing this. Look, with almost all of these, there was, I won't say a crisis, but there was a big motivating factor for change that made them reach out and really want to get real-time information versus, as I said, the Post-it notes and clipboards and Excel spreadsheets that run around. So with that, I'll end this. We always say to people, just try something. Try one thing. Take your most low-hanging fruit, your biggest payback, and just try something. It's fairly low cost. $300, $400, $500 to kind of dip your toes in the water and start getting familiar with industrial Internet of Things, real-time monitoring of machines and processes. So thanks for listening, and hopefully you'll go out there and increase productivity and lower maintenance costs for your operations. Thanks.
Gary, thank you so much for taking time out today. And we've got just a little bit of time left. So there was an early question about challenges connecting to older equipment, but I think you touched on that pretty well with your discussion about all the different equipment and tactics you can to capture information.
That's always what concerns people, and I can tell you, every place we walk into is a giant hodgepodge mess of machines built in every decade, and usually, there's a way to get something useful from them. So
that's good to hear. And one more, it looks like we're just about out of time, but one more. Our clients are understandably very concerned about the security of their production and process data. So can you briefly comment on cybersecurity and what is about your solutions that allow your clients to rest easy that their data is secure?
Yeah. So all the data is encrypted in transit and at rest. We do get into the cybersecurity discussions. We have filled out questionnaires with the largest companies in the world. Pfizer, we just did 14 at a big Pfizer factory. They have a big cybersecurity team. We run penetration testing tools on the cloud platform, and as I said, all the data is encrypted. As IT people would say, in transit and at rest in the database. People certainly have an option to do their own thing on-prem if they have some SCADA system on-prem. The electronics that we do can talk to those using things called Modbus TCP over Ethernet and things like that. As I said, the data is ultimately at AWS, Amazon Web Services. They are saving data for the CIA and hospitals under HIPAA regulations, et cetera, et cetera. So it's all about encryption and, as I said, running, they're called penetration testing tools on the servers that we run weekly. As I said, we have gone through the process with the largest companies in the world, and they are moving forward.
I appreciate that very much, Gary, and I'm sure the listeners do. It sounds like you've got those concerns fairly well addressed. Thanks for your attendance today. Especially thanks to Gary Kiliany, our presenter today, and I hope you found it interesting. And we look forward to seeing you in future webinars the next one coming up in 2 weeks. Thanks, everyone.
Thanks.
Have a good rest of your day. Especially thanks, Gary.